In this tutorial, you will see how to create finishing toolpaths. We will look at some of the model analysis tools, define suitable toolpaths for part regions, and use boundaries and collision surfaces to define and control toolpaths. We will also utilize background processing. We'll start by analyzing the part for the finishing operations. Autodesk Powermill has a number of visual tools to help analyze your parts. Under the shading icon menu, either in the right-hand toolbar or the ribbon, we can select the draft angle shading. This quickly helps us identify any areas that are potentially undercut and which may require multi-axis machining. By default, green areas are accessible, yellow areas are in a warning zone, and red areas are vertical or undercut. We can adjust the settings in the model drawing options. To verify if we have any undercuts, we can change the draft angle to something like -0.2 degrees and the warning angle to 1 degree. Note most of the red model faces go yellow, except for the bottom face, indicating that we do not have any undercuts to deal with. The minimum radius shading provides a quick visual indication of the minimum tool sizes required to machine the part fully, where red areas indicate that the chosen tool radius is too large. Again, the model drawing options allow us to adjust this value. For example, iterating from 10mm downwards until the red regions have gone. We can then take a more focused radius measurement, for example in this pocket, using the measure tool to identify that the radius is exactly 2mm. For the first finishing toolpath then, we will address the two small pockets. From the database, search for a tip radius tool with a tip radius of 2mm. Select the TRD10 tool and create it. From the Home tab, change the selection mode to Drag Select. The selection mode changes to perform a Paint mode selection. Select the inner area of the two pockets using the left mouse button and the Shift key. Other parts of the model can be hidden from view using blanking. This can be accessed in many ways, including via the View tab in the ribbon, or by using the shortcut key by pressing Ctrl and K to blank everything except the selected faces. The selection mode can now be changed back. Create a user-defined boundary called Pockets and insert the selected model faces. Unblank everything again by pressing Ctrl and L. We will create a steep and shallow finishing operation for the pockets. So let's clone the semi-finishing toolpath. Rename it to be Pockets and set the limit to keep inside our new boundary. Set both toolpaths to spiral, but the shallow toolpath cut direction to conventional. We will be using a step down of 0.5mm and a step over of 5mm. We will also set a higher tolerance of 0.1mm and our thickness will be 0. Calculate the toolpath. In this case, the toolpath is also cutting the top of the part, so let's modify the limits. Go back into the settings and recycle the toolpath to allow us to change the settings. In the limit section, set a maximum Z value using the pick icon. Viewing from the side may make this easier. We will also have a 2mm tip radius, so we need to remove this from that Z height also to keep inside the pocket. The toolpath can now be recalculated. Next, we will tackle the split faces of the core. We will utilize a raster flat toolpath to machine the flat areas of the part first. From the strategy selector form, we will select a raster flat finishing toolpath. This toolpath will identify flat areas of the model and produce a raster toolpath across them. Let's call it Raster Flat Finish and select our 20mm flat end mill. From the raster flat finishing section, our step over will be 8mm. We will also uncheck the automatic collision checking and instead look at some other ways to control the machining areas. We will create a simple boundary around the areas we want to machine. From the top view, select the outer split faces using the left mouse button and Shift key to create our user-defined boundary. Rename it Raster Flat and insert the model and accept. Create a duplicate of this boundary for later. Go back to the settings of your Raster Flat finishing toolpath and use this boundary, but make sure the trimming is set to keep outside. To avoid coming into contact with the material on the back here, we will also collision check some of the surfaces. From the component thickness form, shift select the two faces in the graphics window and selecting line 0, press the Acquire Selected Components. Set the machining mode to be collision and change the thickness to 1 mm. This will keep the tool away from these specific surfaces while still machining everything else. Hit accept and calculate. Delete the unwanted segments at the bottom of the part. The toolpath segments can be visualized easier by toggling the leads and links. But let's keep them on for now. The remainder of the split surfaces will be machined with a 3D offset toolpath. For this toolpath, we will use a different tool. From the database, search for a ball nose tool, select the BND8 tool and create it. Again, we will need a boundary. In some cases, you may want combinations of boundaries to machine the exact desired area. This time we will create a boundary from 2 shallow boundaries with different settings to avoid the areas that the flat finishing found. In the form, call it shallow and select an upper angle of 60 degrees and a lower angle of 0.001 degrees. Select the new ball nose tool as the reference and set a limit boundary using the outside of our duplicated boundary. Press apply and accept. Duplicate this boundary and modify the lower angle to be 1 degree and apply and accept. We will now clean up both boundaries and apply them into one. In the first boundary, remove all of the segments except the 2 larger ones shown here. In the second boundary, remove all of the segments except these 3. To append boundaries, we grab the second boundary and pressing the Control key, drag it over the first boundary. A plus icon will appear, indicating the boundaries can be appended. This boundary now covers the areas that we want to machine. Create a 3D offset toolpath and rename it as 3D offset. We will define the limit as working inside the new boundary. In the 3D offset finishing section, switch spiral, smoothing and centerline on and set a step over of 0.5 mm. Autodesk PowerMill has a capability to calculate toolpaths in the background whilst working on other operations. To do this, press the Q button. The toolpath is sent to the background. We can check the process queue from the icon in the status bar. Whilst that is calculating, let's add the previous operation to the stop model and calculate it. Once added, the rest material helps visualize the areas that have been fully finished. Once the background toolpath has finished calculating, add this toolpath to the stop model and calculate the rest material. Identify that no material remains in the areas we have just finished. Save the project to complete this tutorial.